Hey guys, I'm going to talk about simplifying surds today. So we know something's a surd if it can't be simplified without a square root, or if when you evaluate it you get something that's not an integer. For example, the square root of 400 is not a surd because I can write that as 400 to the half. And then I can say, well, it's actually 4 times 100 to the half, which is 4 to the half times 100 to the half, which is the square root of 4 times the square root of 10. Square root of 4 is 2. Sorry, square root of 100. Square root of 100 is 10. It's 20. All right, I'm getting an integer answer. So that one is not a surd. Looking at what I've done here, I've used two index laws. So the first one being that the square root of anything is that something to the power of a half. Right. The second is when I've got some product to some power, I distribute the power to each of the factors. So it's a to the n, b to the n here. So you can see where I've used those two laws. We don't need to do that every time. In fact, we can go straight from here to here once we get practiced at it. All right, so we are doing these 3 steps, but we don't necessarily need to write that every time. So if I think about the square root of 63, well, 63 I can write as the square root of 9 times 7. Right, 9 times 7 is 63. Now I can split up that square root using those two index laws into the square root of 9 times the square root of 7. Now the square root of 9 is 3, and the square root of 7 I can't simplify. So here we have an example of something that is a surd. I can't evaluate that and get an integer answer, get a whole number. It's not a perfect square. So when I do this, I'm looking for factors that are perfect squares. If we have a look at another example, the square root of 8, I can write as the square root of 4 times 2. Now I chose 4 because that's a perfect square, but I'm limited with 8 with my factors. And then I can write this as the square root of 4 times the square root of 2, which is 2 root 2. Alright, if I look at some different stuff that I can do, if I've got, say, 2 times the square root of 3, times, let's say 4 times the square root of let's say, 12. I can think of this as 2 times 3 to the half times 4 times 12 to the half. And then I'm grouping all of my whole numbers together. Say that this is 2 times 4 times 3 to the half times 12 to the half. Converting this back to my square roots, I can say, well, this is 8 times the square root of 3 times the square root of 12. And if I go backwards from what I've been doing, I can say this is 8 times the square root of 3 times 12, which is 8 root 36, which is 8 times 6. Eight times 6 is 48. And so we've essentially taken something that looks quite complicated and discovered that it actually is just a whole number. So that is how you simplify surds. You're using these two index laws, but you don't need to write them every time. You can go straight to this rule, breaking it up into its perfect square factors, evaluating what you can and leaving what you can't. So here we had one perfect square factor in the 9. We couldn't do anything with the 7. So we've left our answer as 3 root 7.